Okay, so tomorrow we're starting our spiraling and we're going to review polygons and quadrilaterals. So I really wouldn't worry about going over the terms because that's how I've got it set up here. So first I'd ask them to say polygon and then say, okay, well, let's talk about a polygon's attributes. And go, if you don't remember what attributes are, let me use it in a couple of sentences. If I asked you for attributes about Mrs. Wilson or the attributes regarding what your house looks like, I mean, use it in a couple of sentences. Or if I said to list the attributes of our school, what you're doing is you're describing. So attributes are descriptions. You could even think of them as characteristics. And y'all could even write that up here, like maybe that would be better. Characteristics. Attributes are descriptions. Well, if it would help if I could spell descriptions. All right, and say, let's see how much y'all remember, because this is not new stuff. Now we're reviewing to get ready for benchmarks and for STAR tests, just to make sure that we are ready to rock, because we're going to make the highest scores ever in 3rd grade this year. All right, polygons are flat, blank, blank, plane. Now, what's that other word? Maybe they'll remember two-dimensional. Or if they say 2D, say that's correct. What does 2D stand for? 2D means two-dimensional, meaning there are 2 dimensions you can measure. You can measure length and width. 2D, 2 dimensions that are measurable, length and width, which makes sense because if something is flat, which means the same thing as plane, they're synonyms. Oh, and I'm recording, baby. These are synonyms. Pick up a piece of paper and I'm like, this is flat. This is a 2D object. When you only have 2 dimensions, when you only have length and width, you're flat. But if you grab something that has length, width, and a little bit of height, now you're 3-dimensional. So that's what dimensions are, measurable sides. All right, so polygons are flat. They are blank, no openings. Closed figures. And blank edges, straight. So this is just reviewing what a polygon is. All right, so over here, these are polygons. Why are these polygons? And ask them, what makes these polygons? Yes, they're all closed. Yes, they use straight edges. Yes, there's no openings. Yes, they're flat. All right, so let's talk about, before we name them, let's do some examples. Those are examples, right? Actually, no. Change my mind. Come over here. So if let's count the edges. 1, 2, 3. 3 is tri, as in triangle, right? 3 angles. All right, let's count the vertices. Do y'all remember what vertices are? Yes, the corners where the edges meet. 1, 2, 3, 4. If you have 4, you're like the word quad. 4. Now, technically quad is quadrilateral. Y'all say that word, quadrilateral. Say it again. But quad is also acceptable. But quad has 4 letters, just like a quadrilateral is 4-sided. It has 4 vertices. All right, let's look at the edges. We have the angles. 1, 2, 3, 4, 5. If you have 5, what do we grab? Grab your pen or pencil. How many fingers are you using to grab? 5. Pen, as in pentagon. Pen, so if it's 5, like your 5 fingers, it's a pen, as in pentagon. Remember that gon means you are a polygon. So a pentagon, and I would get up at this point to go check that they've copied everything, but I would talk as I'm walking around. So a pentagon is basically saying, hey, I'm a polygon, I'm flat, I'm closed, I have straight edges, but I have 5 vertices, I have 5 angles, I have 5 edges, angles, vertices. But gon means I'm a polygon with 5. All right. 6. If you have 1, 2, 3, 4, 5, 6 edges, how do you spell 6? S-I-X. Yeah, 6 is the one with the X in it. Hexa. Hexagon. Meaning I am a 6-sided polygon. There's no trick to 7. 1, 2, 3, 4, 5, 6, 7. And by the way, if you notice, I'm reminding them, even though they don't know it, how to name these. You can count edges, you can count vertices, you can count angles. 7, here's how I remember it. Hexa is 1, hepta is the one that follows. Heptagon. Hepta is 7. Gon, what does gon stand for? Right, polygon, what does that mean? Yes, it means it's closed. What else? Straight edged. What else? 2D, yes, figure. Good. All right, let's count the edges. 1, 2, and as y'all are counting, I expect y'all to be making marks, or you could be highlighting. 4, 5, 6, 7, 8. 8 should be easy. The animal with 8 tentacles is an octopus, which makes this an octagon. Octa meaning 8. Gon meaning, yep, 5-sided, or 8-sided polygon. All right, let's find the vertices. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, how do you spell 9? 9 is N-I-N-E. That N, 9 is nonagon. Nana, 9. Or like my Nana is 90, she's old, 9s. All right, and then this one, we've got, I'm going to show you that we could, instead of hashing, we can count, instead of putting hash mark through the edges, we could highlight and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, do y'all remember what 10 is? If I've been alive 10 years, I've been alive, yes, a decade, deca. A decagon. Deca meaning 10. Gon stands for what? Polygon. How do you know these are all polygons? All right, what's another word instead of flat? What's another word instead of 2D? Yes, plane, as in a plane figure. What else? How else do we know? Yep, there's straight edges and, yes, closed. Very good. Now, which one do you think is irregular? Yeah, the nonagon. Irregular, I think about it like this. You've got regular, and then you've got irregular. You're like, whoa, what's up there? Irregular. To me, if it's a regular looking shape. Now, I've seen that regular means the angles and the edges are all congruent. Same size, same shape. So they would consider that irregular, which to me, that's regular. Examples. So what if I said I wanted y'all to make a heptagon? How many edges does a heptagon have? You look over here, 7. All right, check it out. We're not going to make a regular. We're going to make an irregular. I want y'all to watch me do it, and then you do it. 1, 2, 3, 4, 5, 6, 7. Does it matter what it looks like? Nope. To be a polygon, I just have to make sure that my edges are straight, that they connect, and that it's flat. And to be hepta, you have to be 7. Well, 1, 2, 3, 4, 5, 6, 7. You can copy mine or you can make your own. I'm going to come around and make sure. And then I want you to prove that it is a heptagon by either highlighting or finding vertices. All right. And then we're going to draw a decagon. If you've been alive a decade, how many? 10. So I just need to make sure that I use 10 straight edges that connect. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Voila, decagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's just giving them practice of drawing. All right, these are examples. Non-examples. What could be a non-example? Like, how would you draw a non-example? Can y'all... Okay, yeah, a cube. All right, so if y'all draw a square, and then draw another square in the top right corner, try to make them congruent, same size, same shape. All right, and then you take the top left to the top left, top right to top right, and you're connecting the vertices. Why is this not a polygon? Ah, because it's 3D, 3 dimensions. It has length, width, height. How else can we make it a non-polygon? Oh, a curvy side. So if I did a heart. If there's a curvy one, it's not a polygon. Curves. Curves are no-nos. What else? Ah, an opening. So what if I did something like a swirly like that? Yeah, that's a no-no because it's not closed. And it's curvy, right? All right, so that's just, I mean, to me, this is a big part of your teach piece. This is the discussion. All right, and then down here, we're going to name these. So, Landon, how can I name a polygon? What could I count? Edges, all right. So here we go, 1. So y'all count with me. 1, 2, 3, 4, 5, 6. If you have 6 X edges, what are you? Very good, you're a hexagon. What if I didn't remember that on my assignment? Oh yeah, I could come right over here to my notes, right? Genius. All right, y'all count the vertices on this next one. Let's count them together, and as we count, we should be proving them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you have 10, yes, deca. You've been alive a decade, you've been alive 10 years. If you're a decagon, you've got 10 edges, 10 vertices. All right, on this one, let's count the edges by highlighting. So together, 1, 2, 3, 4, 5, 6, 7, 8. What animal has 8 tentacles? Yep, the octopus. So an 8-sided polygon is an octagon. All right, I'm going to move him fast forward. 1, 2, 3, 4, 5, 6, 7. That's the hepta. 1, 2, 3, 4, 5. Pen. Grab a pen with 5 fingers. That's your pentagon. I'm going to do angles on this one. 1, 2, 3, 4. If you have 4, you're like the word quad with 4 letters. What does quad really stand for? Look at the title if you're not sure. Yes, quadrilateral. All right, and this last one, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 with the ends, nona, nonagon. Okay. And then, eek. Here's another big part, quadrilaterals. Quads. Highlight the word quad, the root word quad. How many letters are in quad? 4. Yes, quadrilaterals have 4 edges, 4 angles, 4 vertices. What are edges? Oh yeah, that's just sides. All right, so this is review of our quadrilaterals, which can be kind of cray-cray. So we've got them in a chart right here. All of these shapes are quadrilaterals in my box. How do I know these are all quadrilaterals? Because they all have 4 edges. What else do they have 4 of? Yeah, 4 vertices, like 1, 2, 3, 4. They have 4 edges. What else do they have? Yeah, 4 angles, like right here. 1, 2, 3, 4. All right, how do I know these are all polygons? Yeah, they're flat, straight, yep, closed, good. Now, quadrilaterals get classified. They get grouped. So you've got trapezoids. which are quadrilaterals with blank pair of blank line segments. Does anyone remember how many pairs it has? Maybe someone remembers it has one pair. One pair of what? They may not remember that. Parallel. Parallel. Trapezoids have one, they're a quad, so they are a four-sided polygon with one set of parallel. Now remember, pairs have two, like a pair of shoes. It takes two shoes, a pair. One set has two in it. And parallel tells you right there, it's line segments that run side by side and never touch. So with our pencils, I want y'all to extend the top. Actually, I want y'all with your highlighter to extend the top and bottom. No matter how far we draw these, they're never going to touch. Now with your pencils, I want you to extend, stretch the sides. What happens? Yeah, they touch. A better word than touch is they intersect. So that's not parallel if they intersect. One set, trapezoid. Let's look at this guy, because he's not under trapezoid. I want you all to extend the side edges. And what do we see? Yeah, what's a better word than they meet? Touch. How about they intersect, like cars meeting at an intersection? Okay, now with your highlighter, extend the other ones. And you may have to draw a little bit. Eventually, guess what's going to happen? They're going to intersect. So these intersect, So how many sets does it have? 0, which only makes it a quadrilateral. All we can say is, dude, you're a polygon and you're a quadrilateral. You don't have a name. But if you're quadrilateral with one set of parallel edges, bam, trapezoid. Now notice that all of these are in this big bubble. This big bubble is called parallelogram. The root word being parallel. Parallelograms, which is everything in this bubble, are quads. They are the four-sided polygons with two pairs of parallel edges. Parallel. Two pairs. So I want us to prove that. So I want you to extend the top and bottom of all four with your pencils. And I'm going fast forward and not as neat. I would do this neater in the classroom. And then extend the sides with your highlighter. And then after I had them all do that, I'd say, all right, let's look back. Parallel once, parallel twice. If you're parallel, parallel, parallelogram. Parallel, parallel, parallelogram. Y'all say it with me. Parallel, parallel, parallelogram. Parallel, parallel, parallelogram. If you're parallel everywhere, parallelogram. Sounds like Baymax. One set, you're trapped. You're trapped right here in this one set. There's only one way to go. Trapezoid. Parallel, parallel, parallelogram. All of these are parallelograms. Well, then you get specific. Let's go over here. If you are a parallelogram, which means you are a quadrilateral, what does that mean? Yep, you have four edges. If you're a parallelogram, which means you have parallel, parallel twice. And this one, I want you to put 1 equals 1 equals 1 equals 1. How many of its edges are congruent? 4. What does congruent mean? Let's write that off to the side. What is congruent? Same size, same shape. They may say equal and say that's true, but technically it's same size, same shape. You definitely could say equal because if you are the same size, you are equal. Equivalent would be even better. So if I'm a parallelogram with 4 congruent edges, you can call me a rhombus. Now, if you're a quadrilateral, if you have 4 edges and you're a parallelogram, you're parallel, parallel, and you have 4 congruent edges, 1, 2, 3, 4, 1 equals 1 equals 1 equals 1, and you have 4 right angles, then we call you a square. Now, right angles If you don't remember, they're losers. They make a capital L that's 90 degrees. So right angles are losers, and no matter how you turn it, they're a loser. So the rhombus right here, well, let's go to the square first. If you get in this corner right there, that angle is a loser. And over here, it's a backwards loser. If you can make that capital L, you've got a right angle that's 90 degrees. Look in this rhombus. That is not a capital L. That's like a little chicken beak. And then these are bigger than capital L's. They open up like into a mouth. So if you're a parallelogram, that means you're parallel once, you're parallel twice. If you're a parallelogram with 4 equal sides, you're a rhombus or a square. Because, right, notice how square, if it's in the middle, it's both this and this, right? This is a rhombus. This is a square. Why is he a square? What's the one thing different about him from the rhombus? Yeah, it's the right angles. So if I'm a rhombus with 4 right angles, then you call me square. Can the square go play with the rhombus group? Yes. Why? Because the square is a parallelogram with 4 equal edges. Is a rhombus a square? Well, think about it like kids. Here comes the rhombus group. Hey, square, we want to play with you. Can we hang out? And square goes, well, you got to be a quadrilateral. You got to have 4 edges. And the rhombus goes, I do. Oh, yeah, well, to hang out with us, you better be a parallelogram, parallel, parallel. And the rhombus goes, I am parallel, parallel. Oh, yeah, well, to hang out with us, you better have 1, 2, 3, 4 edges that are equal. Rhombus goes, I do. Look, 1, 2, 3, 4. They're all congruent. Oh, yeah? Well, we also have 4 right angles. Rhombus goes, man. Yep, you can't play with us. A rhombus is not a square. All right, look at the rectangle. Is it a quadrilateral? How do you know? 4 edges. How do you know it's a parallelogram? Well, parallelograms have 2 pairs of parallel segments. Parallel, parallel. Right angles. Well, right angles are losers. So let's see. 1. That's a capital L. 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 So 4 right angles. Now wait, who else had 4 right angles? Yeah, the square. Well, why is this not a square? Because squares not only have right angles, they also have 4 congruent edges. Does this guy have 4 equal edges? No. Here's how you would look at a rectangle. 1 equals 1, right? This length equals that length. But then 2 equals 2. As in, this one is equal to that one. Opposite sides. So, is a rectangle a square? No. Why? Well, because here's the squares are like snotty kids. They're like, we're the mean group. Squares are. Rectangles are like, can we play? And squares are like, well, you better have all of my attributes. You better have all my descriptions to be a square. Are you a quadrilateral? Yep. Are you a parallelogram? Yep. Do you have 4 congruent edges? Nope. Then no, you can't come play with us. Oh, yeah, well, you can't play with us either because you have to have our attributes. And square goes, okay. Well, rectangle goes, I'm a quad. And square goes, me too. Rectangles go, oh, yeah, well, you got to be a parallelogram. Square goes, I am parallel, parallel. Rectangle goes, yeah, well, you better have 4 right angles. Square goes, psh, I do. I'm coming to play with you. Squares are rectangles. Squares are rhombuses. Squares are parallelograms. Squares are quadrilaterals. Why? Well, why is because a square has all the same attributes as the rectangle. Say attributes. A square has the same attributes as a rhombus. Say attributes. Meaning they have the same descriptions. So, let's look down here. Girls, read us about Faye. All right, well, what do we know? Faye's poster has 4 equal lengths. Well, and we want 2 quads. Which quadrilaterals have equal lengths? Yep, squares and rhombus. Good. And make them say the words, not just write them. All right, boys, read us about the paper. All right, so we want 2 quadrilaterals to represent piece of paper. Well, what do we know about the piece of paper? It has 4 edges, which makes it QUAD, a quad. 2 sides are the same length, and another 2 are the same. So it doesn't say that it has 4 equal. It says 2 are the same and 2 are the same. So if we take out the equals, which 2 quadrilaterals have 2 that are the same and another 2 that are the same? Yeah, here's 2 that are equal, and these 2 are the same. Who else? The parallelogram. 1 equals 1. 2 equals 2. So we would write rectangle and parallelogram. Kevin?
Oh, let's go brush teeth.
Both of them. Quadrilaterals. We want quads that are parallelograms. Well, what does it mean to be a parallelogram? Parallelogram. Parallelogram. You better be parallel everywhere. You better have 2 pairs, right? So look up here. Who's parallelograms? Yep, the rectangle, parallel, parallel. Who else? Square, yep, parallel, parallel. Who else? Rhombus, yep, parallel, parallel. That's 3. No, that's only parallel once. Yeah, parallelogram, parallel, parallel. Now, if you have time, great. Fill it in and write it. If not, oh, and I don't even have a space for parallelogram. If you have time, write it because it helps with the spelling and the read it, write it, say it. If you don't have time, then I would just say it out loud. Although I think y'all should be all right. Which quadrilateral has 4 congruent edges and 4 right angles? So I need a quad, QUAD, with 4 congruent edges, 4 right angles. What does congruent mean? Same size, same shape. So which quadrilateral is that? Yes, the square. Why? Are you sure it's not the rhombus, though? Oh, you're right. It has 4 congruent edges, but what does it not have? Right. The one who has 4 right angles is the square. So see, you could try and mess them up. Is a square a rectangle? And before we answer, let's look. Is a square a rectangle? Yes, we said it is. Why, though? Why is a square a rectangle? Hopefully they can say, well, a square has all of the same attributes. Squares have same attributes as rectangles. You could say qualities, characteristics. Landon K, get off of that. All right, we want to color the QUAD, quad. So y'all miss this a lot. So look right here. And then count. 1, 2, 3, 4. So is that a quad? Yes. All right, right here. I'm going to do this one. 1, 2, 3, 4. Is that a quad? Yep. What about right here? 1, 2, 3, 4. Is this a quad? And then 1, 2, 3, 4. They're all quads. Who knew? Holding. No assignment tomorrow. Just take that hour or hour and a half. Quadrilaterals. Spend good quality time on each side.